So we get 1.910. Now, this is probably a little bit more challenging because we don't really have a good like number sense of what these values are between 0 and 2 pi. So I just want to go over that super quick. So 0 is 0. Pi over 2, if you plug that into your calculator, is about 1.57. And then pi is 3.14. 3 pi over 2 is equal to, like I said, I'm just plugging these in so that we can get like a good value here. So 3 pi over 2, 4.71. And then 2 pi will be 6 and change, 6.28. All right. 6.28. All right, great. So now our calculator is only giving us one answer. This is the answer in the second quadrant. That's what the calculator does. Now it is up to us to determine what is that value in the third. And this is where it starts to get a little like manipulation tricky-ish wise. So 1.910 is the angle in the second quadrant. So I want to know what is the reference angle so that I can determine what the angle is in the third quadrant. So what I'm going to do is I'm going to say, what is pi minus 1.91? That'll give me the difference, and that will give me my reference angle. So I'll do pi minus 1.91. Okay, 1.23. Now, I know that's a reference angle because it's a positive acute angle. And I know it's acute because it's less than pi over 2. It's less than 90 degrees. 1.57 is 90 degrees, 1.23 less than that. So that's my reference angle. So in the third quadrant, what I'm going to do is I'm going to add 1.23 to pi. We'll get 4.37. All right, so these questions, when you say, oh, we get a calculator, yeah, that makes it a little bit, like you have a little bit of a, crutch to kind of fall back on. But I actually think these problems are a lot trickier because you got to do a lot of more manipulation in order to get what you need. So 1.910 is our angle in the second quadrant. That's the one they automatically give us. And then to find the angle in the third, we had to determine what the reference angle was, work backwards a little, and then add that reference angle to pi. All right, so we're going to see one more. So solve 2 cosine squared t minus 9 cosine t is equal to 5. All right, without thinking too hard about this, if you ever see something squared and then like the regular thing in the same equation, it's probably a quadratic. So I'm going to get everything over to one side. So I'm going to bring this 5 over. All right. Now, if this is a little intimidating to you, that's totally fine. Just like write the quadratic that this kind of looks like. And this is a strategy we're going to do a lot in this chapter. So this kind of looks like 2x squared minus 9x minus 5. Now, if you're not a great factorer, there's a couple of different strategies you can use. So I know that I have to get 5, so like this one's kind of nice because there's only one way to get 5 is 1 and 5. And I know 2 times 5 is 10, and that if I subtract 1, I can get my 9. The 9 is negative, so the bigger number is negative. So this looks like 2x plus 1, x minus 5. A couple of different ways to do it. If you don't even like it this way, you can of course use the quadratic formula. Not a big deal. If you need factoring help, let me know ASAP because we're going to factor a lot here in this unit. So this is going to factor just like this, but with cosine of t instead of x. So 2 cosine t plus 1. Cosine t minus 5 is equal to 0. So that's what it looks like. All right, and we solve this just like we would solve any other quadratic. And actually, I'm going to do the easy part first. Let's cosine t minus 5. Cosine of t minus 5 is equal to 0. Cosine of t is equal to 5, which is never possible. Cosine has to be less than 1, greater than negative 1. So not possible. Nope, not going to happen. So we get to move on. And we get to move on and factor and solve this factor. 2 cosine t plus 1 is equal to 0. Cosine of t is equal to negative 1/2. They want all of our answers between 0 and 2 pi. I want my radian measures. So cosine is 1/2 at your pi over 3s at your 60 degrees. So it's negative in the second and it's negative in the third. The pi over 3 in the second quadrant is 2 pi over 3. And the pi over 3 in the third quadrant is 4 pi over 3. So these are my two answers. We actually didn't need a calculator. And like, look how fast that went, even compared to these two questions. So I actually really, like, I showed you the calculator questions. You think you have a couple in your homework like it, but the non-calculator is where it's at. They're going to be a lot easier for you to manipulate and work with and just think about logistically and theoretically on that unit circle.